Hi everyone. I hope you're okay, and I really hope, guys, that the videos I keep uploading to you are very helpful. Today's video is about proving identities, the greater of identities, to be exact. This video is about proving identities, right? Okay. Before I prove identities, let's establish our identities. I know that I've taught this in the first few videos, no? The first 4 videos that I've uploaded. So I have square identities, and square identities are sin squared theta plus cos squared theta is equal to 1, cos squared theta is equal to 1 minus sin squared theta, which can be further factorized to 1 minus sin theta and 1 plus sin theta, because it's the difference of two squares, right? Then the third identity, I have sin squared theta, which can be written as 1 minus cos squared theta, that can be further factorized into 1 minus sin theta 1 plus sin theta, all together. And then for those who are using sec, cosec, and cot, maybe you might need this 1 plus tan squared theta is equal to sec squared theta, and then 1 plus cot is equal to cosec squared theta. These are the square identities that you will need. Reciprocal identities, we have sec theta, which is equal to 1 over cos theta. So whenever we see sec theta, just substitute 1 over cos theta. Whenever you see cosec theta, you just need to substitute 1 over sin theta. Whenever you see cot theta, you can put 1 over tan theta, but it's advisable to just substitute the reciprocal identity, not rather, but the quotient for cot, ne? Your quotient identities. This will be a long video, guys. Please brace yourself. Tan theta is equal to sin theta all over the cos of theta. The second one is the cot of theta, which is equal to the opposite of sin of tan, rather. Okay, when it comes to grade 11 work, these are the identities that you need, ne? And then for the metric part, you will need compound angles. If you have sine of A and B, ne, you will definitely have sine A. You will definitely have sine A and cos B. Then you'll have cos A and sine B. Please note that if you have a plus here, you'll also have a plus, but if you have a minus, you'll also have a minus here. All together. And then for cos A and B, you'll have the cos of A multiplied by the cos of B, sine of A multiplied by the sine of B, ne? So if you have a plus here, you will have a minus there. But if you have a minus here, you will have a plus there. Add together. That's how the compound angle for cos and sine work. Will you need? No, I won't need for tan. And then we have the double angle identity. For sine, it's just simple, ne? Sine 2 theta is 2 sine theta cos theta. Please remember the relationship, guys, between these, ne? The angles here, these angles are half of this one. That's the relationship between the double angles, ne? This one is for sine, and then for cos we simply have 2 cos squared theta minus 1. We have 1 minus 2 sine squared theta, and then we have cos squared theta minus sine squared theta. Please, guys, go and check lesson number 30 on how and when to use the compounding double angles if you're struggling, ne? Okay, these are the angles that you will use, ne? Remember that, guys, you always follow the simple steps. Always follow the simple steps, ne? Step number 1, we reduce angles. Step number 2, we check if there are two things we change into one thing, ne? Basically, this thing is telling us to focus on the square identities. And then the third rule just says change everything into one trig ratio, but sometimes you cannot do that. If you can't do that, just change into sine and cos. Just change everything to sine and cos, ne? Okay. Let's try and do these things. For the first one, we are supposed to show that cos 2p all over cos of p minus sine of p is equal to the cos of p plus sine of p, ne? Okay. Here I'm supposed to simplify my left hand side, and as I can see that on my left hand side, at the top I have cos 2p, at the bottom I have cos p minus sine p all together. So in this case, there's nothing I can do to simplify the bottom part, but I can try to simplify the numerator all together by changing the identity there, by using the one that has two trig ratios. Are we together? Guys, please remember the steps. You must reduce angles. Angles are already reduced. Check if there are two things that you can change into one thing. There are no square identities here. And then now we are trying to change everything into sine and cos. Are we together? So we have two trig ratios that you cannot change there at the top. So we will simply use the double angle that has two of the trig ratios for cos. And then this thing is still cos p minus sine p. Are you together? But at the top, this thing it can be factorized because we have a difference of two squares. So we'll simply say cos p minus sine p, and then cos p plus sine p all over cos p minus sine p, and then this will go with this one. I will be left with cos p plus sine p. Then the left hand side is equal to the right hand side. Are we together? Okay. Let's try the next one together. You can pause the video, guys, and try it on your own. You're supposed to prove that cos to the power 4 theta minus sine to the power 4 theta is equal to cos 2 theta. Every time, guys, you must always simplify the side that looks the most difficult, you know? Okay, this thing is I see difference of two squares there on the left hand side, so I can simply factorize this thing. The square root of cos to the power 4 theta is cos squared theta. Cos squared theta. The square root of sine to the power 4 theta, sine squared theta. Then I have minus and plus. Please note that I have cos squared theta minus sine squared theta. There are two things that I can change into one thing. Cos squared theta plus sine squared theta is just 1. So I'm multiplying by 1 now. Together, I'll be just left with cos squared theta minus sine squared theta. Because if I multiply something by 1, it doesn't change. But I know that cos squared theta minus sine squared theta is an expanded version of the double angle for cos. So now I've proven that the left hand side is equal to the right hand side. Okay, let's do number 7 together. They want us to show that sine A plus cos A all squared is equal to 1 plus sine 2A. Okay, they want us to prove here. Here we can simplify either the left hand side or the right hand side. It will be the same, no? Okay, let's simplify the left hand side. Since you have a bracket squared, you can open two brackets if you want to, or you can just expand the bracket right away. You'll have sine squared A plus 2 sine A cos A plus cos squared A. Guys, this is the same as having something like this: 1 plus x all squared. Ne? Whenever I expand this, I square the first term, I'll get 1. Then for me to find the middle term, I'll multiply the 2, I'll get x, and then the product that I'll get, I'll multiply with the exponent, which is 2x, and then I just squared the last term, I'll get x squared. This is what I did here, guys. Trigonometry and algebra, guys, are the same thing. Don't get confused. Don't get confused, okay? Please note that the sum of these two will give us 1. Are you together? And then this is an expanded version of the double angle for sine. So you can simply say plus sine 2a. Are you together? But if you wanted to simplify the right hand side, you could have done it as well. We have let me write this in red. You have 1 plus sine 2a. 1 can be written as sine squared theta, sine squared a plus cos squared a, and then you can even expand the double angle for sine there. It's sine 2 sine a cos a, and then we can express this thing in a manner that we will be able to factorize it. Out of sine a plus 2 sine a cos a plus cos a squared. No? Then I'll just have to open 2 brackets. I'll have sine a there, sine a cos a, and then I'll have plus and plus, which will give me sine a plus cos a all squared. So it's up to you guys. You could have done it by simplifying the left hand side, or you could have done it by simplifying the right hand side. You'll still get the same answer. Okay, now we must show that sine 2a is equal to 2 sine a plus 2 cos a, right? All over sec a plus cosec a. So here the most complicated side is the right hand side. So I'll simply say the right hand side is equal to 2 sine a plus 2 cos a, ne? And then all I need to do, guys, is to just change these things and write them in terms of sine and cos. I'll have 1 over cos a plus 1 over sine a, like that. Are we together? And then but there at the top I could have just taken a common factor. Let me just do it. There's a common factor there at the top, no? I'll write it in red. The common factor is 2. We can all see that. The common factor is 2. And then now, guys, I don't like having fractions within a fraction. Are you together? So my duty will be just multiply the top and bottom by the LCD. My LCD, it will be sine a multiplied by cos a. Sine a multiplied by cos a. Are you together? And then I'll have 2. The brackets will be there, sine a cos a, and then I'll still have, let me write this one in blue, I still have sine a and cos a. Then at the top, whenever I multiply this thing by the LCD, the cos's will cancel. I'll be left with sine a plus, whenever I multiply the second term by the LCD, the signs will cancel. I'll be left with cos a. We can all see that since everything is multiplied here, this will cancel this, and I'll be left with 2 sine A cos A, which is equal to the double angle for sine. So now I've shown that the right hand side is equal to the left hand side. Guys, these things are so repetitive. Okay, and then now we have cos 2x all over cos x plus to the power 3. I must show that this is equal to cos x minus sin x all over 1 plus sin 2x, right? We must always simplify the most complicated side. So the left hand side, I have the double angle for cos. At the denominator I have 2 trig ratios. All I have to do is to change that cos into the two into the identity that has the 2 trig ratios, right? Since I have cos 2x, I'll simply write cos squared x minus sin squared x is all over the bracket. But I can factorize that at the top, right? I can factorize that at the top. I have cos x and sin x, because the difference of 2 squares, right? Please note that I'll just put a minus and a plus there. Remember that I had a cubed there at the top. Okay, so this will cancel one of these. So I will be left with cos x minus sin x all over cos x minus plus sin x rather, all squared. There was a plus there. Okay, I can take out the brackets at the denominator whenever I do so, but let me just write the numerator. Whenever I take out the brackets, I'll have cos squared x plus 2 sin x cos x plus sin squared x rather. All right, together. Please note that I still have cos x minus sin x all over. Please note that the sum of these two terms will give me 1 plus this is an expanded version for the double angle for sine, so I'll simply write this. So now I've proven that the left hand side is equal to the right hand side. Right, together. I was supposed to show that this thing is equal to cos x minus sin x all over 1 minus 2x. That's what I just did there. Okay, now I have 1 minus tan A all over 1 plus tan A is equal to cos 2A all over 1 plus sine 2A. Okay, let's check the left hand side. What do we get whenever we simplify that guy? Remember that we have to change everything to be in terms of sine and cos, right? So I'll simply write 1 minus, and then I'll write sine A over cos A. This thing is all over 1 plus sine A over cos A, right? Whenever I deal with fractions, I don't want fractions within a fraction. I want whole numbers over whole numbers. So I need to multiply the top and bottom by the LCD, which is what? Cos A and cos A, now. So what I'll do here is to multiply 1 plus cos A. I'll have cos A, and then if I multiply the second term by cos A, I'll get a negative sine A all over. Whenever I multiply 1 by cos A, I'll get cos A. The second term by cos A, I'll get plus sine A together. So the left hand side is equal to this. So let's see whenever we simplify the right hand side, what will you get? On the right hand side, we have cos 2a all over 1 plus sine 2a, right? I can see that whenever I expand the double angle for sine, I'll have two trig ratios which I cannot change. So it's always advisable for me to change the numerator with the identity that is also two trig ratios. Remember that 1 can be written as sine. Okay, let's write it as 1 can be written as cos squared A and then cos squared A and sine squared A are together. And then sine 2A can be written as 2 sine A cos A are together. You can factorize there at the top. We have the difference of two squares. So we'll simply write cos A sine A cos A and sine A minus and plus. This thing is all over. Whenever I factorize the denominator, I'll have cos A and sine A cos A and sine A. This is plus and plus, and therefore this will cancel this one. I will be left with cos A minus sine A over cos A plus sine A. Are we together? Okay. Now I'm supposed to show that cos 2 beta plus cos B all over sine 2 beta minus sine B is equal to the cot beta plus cosec beta. Okay, the left hand side, since I have cos added to the double angle for cos, I'll simply change this one to 2 let me express this in red. This thing can be written as 2 cos squared beta minus 1, right? I can still write the cos beta there. I separated the two because I wanted to write the expression at the top in standard form. Okay, the denominator, I can change sine 2 beta into 2 sine beta cos beta. I still have minus sine beta. Okay, the numerator is factorizable, guys, né? Like trigonometry shouldn't scare you. This thing is simply 2x squared plus x minus 1, which you can factorize. So it's still the same thing, guys, né? Okay, I have 2 cos beta, then I have a 1 I have cos beta, then I have a 1. The sign is the 1 is negative, ne? Simply means my bracket will have two different signs. So I'll have a plus there and a minus. And then that at the bottom I can take out a common factor. My common factor is just sine beta. I'll be left with 2 sine beta minus 1. So this guy will cancel this one. I will be left with cos beta plus 1 all over sine beta. Since I only have one term in the denominator, I can simply do this cos beta over sine beta plus 1 over sine beta, right? So this cos beta over sine beta is the same as cos beta. This one is cosec beta. So I've chosen, I've proven that the left hand side is indeed equal to the right hand side. Okay, now I have to show that sine sine 2y plus sine y is equal to cos 2y plus cos y plus 1. This entire thing should be equal to tan y, right? Okay, the left hand side is the most complicated side. The double angle for sine, there's only one double angle, so I don't have to worry myself whenever I change this one. Plus sine y. But please remember that whenever I see a 1 in the same statement as the double angle for cos, my duty will be to eliminate that y, that's 1 altogether. So I'll choose an identity with a negative 1 since there is a positive 1 there in that statement. I'll simply say 2 cos y minus 1. I have a plus cos y plus 1. And another thing that could have hinted that I should change to 2 cos squared y is because I already have a cos there at the bottom, so I can just change into 1 trig ratio. Okay, at the top I have the common factor there, which is sine y. Whenever I take it out, I will be left with 2 cos y plus 1 all over. Remember that the ones are subtracting one another, right? So I can simply erase them here. I can simply erase the y's, and then I'll be left with 2 cos squared y plus cos squared. I can take out the cos squared as my common factor, not the cos squared rather, but the cos y. I'll be left with cos y plus 1. And then this will cancel with this one, and then I am left with sine y over cos y, which will give me the tan of y. Okay, I have tan a. Guys, this thing is repetitive, right? This is my second last thing. After number 14, I believe that I should just wrap it up. Or let me refrain from just doing the one that I've ever caught, because you guys will comment on my complain on my comment section. As man's a cost. Hey, ufundiswa ubani varsity? Siza wena. Okay, I have cos x minus cos x times cos 2x minus 1 over 2 sine 2x. Okay, I'm supposed to show that the left hand side is equal to the right hand side. Obviously the right hand side looks complicated, so I'll simplify the right hand side first. Okay, I have cos x minus cos x and cos 2x. Please note that I do not change this guy before having the clue on which one to change it to, because I have 3 different identities, right? But this one is so simple, I can change it any time, all day, every day. I still have 2 sine x cos x minus cos x. Okay, and then at the top, I'll have cos x minus cos x times cos 2x minus sine x cos x all over 2 sine x cos x minus cos. Okay, I can see a common factor there at the top. My common factor will be cos x. I'll be left with 1 minus cos 2x, and then I have a negative sine x there. All right, together. And then at the bottom, I also have the common factor of cos there. I'll be left with 2 sine x minus 1. These two will cancel one another. I'll be left with 1 minus cos 2x minus sine 2x all over 2 sine x minus 1. At the numerator, I have a 1 there. I must change my double angle identity for cos to the one that will eliminate that one. So I will choose this one. 1 minus 2 sine squared x. I still have a negative sine x there, all over 2 sine x minus 1. Okay, I'll have 1 minus 1 plus 2 sine squared x minus sine x all over 2 sine x minus 1. 1 minus 1 will give me 0, right? So at the top I'll be left with 2 sine squared x minus sine x all over 2 sine x minus 1. Guys, these things are so repetitive, man. The common factor is sine x, and then the common factor is sine x. I'll be left with 2 sine x minus 1 all over 2 sine x minus 1. These two will cancel. I'll be left with sine x. Then the left hand side is equal to the right hand side. Guys, please just take a screenshot. 1, 2, 3 for good. Another one, and the last one for the last two. Guys, please comment on the write on the comment section which one must I do on the next video, because these things, guys, they're just repetitive. I'm just repeating one and the same thing. I hope though the video made sense and you guys understand. So guys, thank you for your time, and thank you for trusting me. I hope guys these videos they're helping you with a thing or two together and clarifying the misunderstandings maybe you had. If you didn't have misunderstandings, I'm glad you're learning something new together. So just comment on the comment section and ask me to do maybe any of these. I can do them anytime, guys. Thank you very much.